Okay, welcome everyone for this month's Nuance Tech Talk. Me and my colleague Xiaoning will be presenting you today the automated wet chemical processes that we have here at NUFAB. Let's begin. All right, we will be talking about typical wet processes we have available for users, just a little brief overview. But the main focus of this topic will be our newest instruments here, the auto developing station and auto mask etching station. Typically, a lot of our users here do photolithography, and this is sort of like a typical process flow. When you do the lithography, you start with your substrate, you apply photoresist on it, you do your exposure, whether you're using a contact aligner with a mask or you do laser writing. Then we develop our resist, and then we etch these substrate. This substrate could be a mask too, by the way. So you can etch photo masks in this manner. So this two steps over here will be the main focus of the talk. And so here I listed what type of processes we offer here. So first of all, if you have liquids in contact with your substrate, that process is called a wet chemical process. That could include like simple DI water rinsing, solvent cleaning, we do mostly when we start processing our substrates. Could be simple acetone and IPA or more stubborn organic residues usually require stronger solvents such as NMP. We have a lot of photoresist developing available at the in the lab here. They are mainly alkaline developers such as metaline-free or metaline-containing developers, or we have solvent developing available for some specific resists. And then we have acid processes. They could be a lot of different things. Most people use buffered oxide etching or HF relevant etches for removing silicon dioxide from the surface or patterning silicon dioxide. We have photomask making, so we have dedicated photomask etchers, which are acid solutions that are used to remove mask material from the glass surface. We have acid combinations to etch semiconductors like gallium arsenide and stuff like that, involving nitric acid, citric acid, and other kinds of buffered solutions. And we have sulfuric acid-based nanostrip for deep cleaning sample surfaces. Right? I try to add like common ones. There may be more, and the acid part will be covered by Xiaoning, and she will go into more detail about it. And we have also alkaline etching for silicon, so we can do KOH etching with different weight percentages that are available. Also, we have tetramethylammonium hydroxide for etching silicon anisotropically. Let's continue. So if we talk about developers, we have mainly 3 different kinds of developers available for you to use. They are metaline containing. We have our most common developer is AZ400K, which is metaline containing developer, which uses potassium hydroxide as its main ingredient. And I listed here their normalities. You can think of this as the strength of the developer. So it's kind of as a measure of how fast the developer will attack the photoresist. And metaline-free developers, we have 3 kinds, and different normalities, or whether they have surfactant in it or not. If you're wondering, the surfactant helps to wet the surface a little bit better, but depending on the type of process you're doing, sometimes you want them or sometimes you don't want them. Mainly if you're doing puddle developing or spray developing, which we don't have actually, but you don't really want surfactants. But the rest, especially with high aspect ratios, it helps a little bit. So that's why we offer 2 kinds. And we also have solvent developer, which is our only solvent developer, which is the SU8 developer, which is a PGME solvent, and it is available for use as well. If you have questions, by the way, you can just put it in the chat window and then we'll try to cover them. So typically what we do, up until now, when before we get these automated machines, we have our beakers or containers and dishes on the bench. You fill one with developer, one with the rinsing agent. In case of alkaline developers, it's the DI water. In case of SU8 developer, it will be IPA over here. So you dip your wafer in the developer, you wait for a set amount of time, depending on the resist thickness. And then you rinse it with water. Then we dry it with nitrogen gas. So that's how we typically do it, right? And I add some tips here just to give you general guidelines, and from experience what we see, especially with new users when they're struggling. So the most important one is using with clean labware, right? So because when it is dirty, you have contaminants and it can change the chemistry of your developer, which will affect your developing time, and then you get inconsistent results from time to time. You might even consider having your own labware for critical processes, and you just use one specific kind of developer with one dish only, right? So that's typically how it's done in production labs, actually. Now, the second thing is often omitted a lot, with especially beginning users, that you have to rinse very well after the develop finishes, because the idea of rinsing is first, it will stop the development process, and also it will clean the substrate surface from dissolved developer, right? Otherwise, you'll have a lot of scum at the bottom of your features, especially around the corners, and you'll get like surface roughness. Maybe if you're doing a lift-off process, you get delamination. So that will cause a lot of trouble. Generally, rule of thumb is you need to rinse at least as long as you develop, right? So if you're doing 1 minute developing, you need at least 1 minute developing. And when users usually ask me, I jokingly say, like, just rinse it as long as you think it's enough, and then double it, right? So there's no harm rinsing it too much. And the other one I see a lot in the lab is that sometimes people just leave their substrates on the bench when the chemicals are on it still. So that's usually a really bad idea, because due to surface tension, or sometimes the surface of your wafer is not very hydrophilic, so the water or solvent, whatever is on it, will start to run, and it will start drying from the edge. And as soon as it dries, it kind of deposits whatever contaminants in there on your substrate, and they will get very hard to clean later. So you should always use a nitrogen gun after your work is done. All right. So that is your most important job. So you have to just you cannot just, if somebody calls you, you cannot go to your phone, and just cannot check your emails. You have to dry your substrate, put it in a safe box, and then you can do whatever you want. Right? The other thing is you should know when to agitate. All right. So it's usually recommended to shake your substrate in the developer during the process, because what happens is the dissolved resist sediments back on the surface due to gravity, and that will slow down the developing process. And that's why we agitate it, to get fresh developer to kind of get down deep in the grooves in the resist. However, this can be counterproductive if you are trying to make very fine, like micron size features, because agitation is not going to be the same each time you do it, so you'll get inconsistent results from one sample to the other, right? So if you're making like very fine features, it's usually better to let it do its job and just time it whichever time is necessary. You can do like a little bit of optimization with a few samples, and then let it like that. But if you are doing high aspect ratios, you have to agitate very vigorously. Otherwise, you will never develop your features fully. And there are practically like a little bit more advanced methods that you can use for high aspect ratio patterning. Mainly those are like cold developing. You can cool down your developer to slow down the developing process, and then that will reduce the dark erosion, which is, the developer will not attack unexposed parts, or attack less the unexposed parts of your resist. Or you can do like hypersonic assist, which is, you can dip your developer along with your sample in the hypersonic bath. That way it will shake off the residues. Or, it can be as simple as like you put your substrate upside down in the developer so that nothing sediments down back onto your substrate, right? And again, we are here to help you. You can ask anytime you have any trouble, right? So just don't hesitate. All right, but we do have problems, always happens, and we try to solve them. But some of them are inherent to the process, some of them are user related. So I try to list some most common ones here, especially with new users. When they don't, when they're not really experienced using like tweezers or sample holders. This can be a problem, because sometimes you need to develop like 30 seconds or even like 20 seconds, and if you drop your sample during the like at the end of your process, then you'll get like over developing issues. Maybe lose your features on the substrate. And when you drop your, when a user drops their sample, they just get panicky and they try to grab it really fast because they don't want to overdevelop it and cause scratches. Sometimes they break their substrates. That's not good either. And that all those things cause like overdeveloping, and your features become wider than they need to be. I already talked about unclean labware, especially if you have like potassium hydroxide residue in the dish and you use an MIF developer. That residue, if even at ppb levels, can change the developing time drastically. So again, you may have inconsistent results. And again, there are safety concerns, like you're dealing with chemicals here, especially TMAH is really toxic, and that's why we generally advise users to just use AZ400K, which is a less hazardous alternative that you can use unless you're making silicon semiconductor devices. Obviously, sometimes you have to use TMAH, the metaline-free developers, but our job is kind of like minimize our contact with hazardous chemicals, so that's an issue. And there's also an environmental aspect of it, because these things are expensive to buy, and they're even more expensive to dispose. So if you can minimize the use of these stuff, that will be good for everybody, right? So to solve all these problems, now we have a puddle developing automatic developer, right? What will happen is, it's an automated process. You don't, there's very deep, precise control over it, and users usually don't need any kind of input. Just press a button, it will do the process for you, and it's dry in, dry out. It's basically hands-free. You put your substrate in, the chemicals will come, and chemicals will go. The substrate will dry, and you just take it out, right? And that allows us to use less developer and will produce less waste. So what happens is, it's like a controlled environment over here. The developer will come from the top, and it will spin, or it will shake the substrate for you in a controlled manner. And when the set time is over, it will just rinse it with whatever the rinsing agent for a specific developer, and then it will dry it for you, right? So it's a pretty good machine, actually. Now it has some already chemicals available. The AZ400K is there, and you can use it with most common resists we use in the lab, like S1805, S1813. You can use it with AZ5214E if you're doing a positive process. And you can use it with AZP4620, which is our thick photoresist for etch mask in deep array. And you can also use this with developing photomasks. So basically, if you write a photomask with MLA 150, if it's an iron oxide mask at the moment, you can just put it in this machine, just press a button, develop it, and then go over there on the acid etcher, just etch the iron oxide over there, and you'll get your mask hands-free, really quick and really simple. All right. The next available set of chemicals are SU8 developer and IPA, which is used to develop SU8. And right now, currently, we have only recipes for SU8 2 and SU8 10. That, you know, if you're using these resists, you can just use the auto developer and just make your developing go smoothly. And you can just use DI water, for example. Sometimes users just need to rinse their samples with water, and you can just do that as well. So there are recipes for that. You just put it in there, and it will just rinse it and then dry it for you. And there is also a spin dry recipe there, no chemicals. So you can just put it in, put your substrate, and it will dry it for you. And we're always developing new recipes. Just you need to let us know, and just even type in the chat right now if you want any kind of specific developers you want to see in this machine. Right now we have expansion ports for 2 more chemicals. So depending on the user inputs, we're willing to add more chemicals into this machine. All right. Now, we have a number of chucks I wanted to show you here, which you can use for different sizes of substrates. Mainly, we can use 3-inch wafers using our 3-inch chuck, and 4-inch wafers goes into 4-inch chuck. We made a specific, chuck for microscope slides. A lot of our users use 1x3 or 2x3 microscope slides, and you can use this chuck in the middle. It can accommodate both kinds. And we have chucks for mask plates, 4-inch and 5-inch, and we have a little basket here for small chips, right? So you can use like from 5mm to I believe up to like 1.5-inch chunks of substrates can fit in this basket easily, so you can just develop them easily. And we can make more chucks if you have some unusual shaped substrate. Just let us know, right? Okay. So I have some high resolution process examples here from the machine. So these are SEM images of high density grading lines that are exposed with MLA 150. I used S1805 for this on this piece of silicon wafer, and after that we developed it using this Osiris developer. And then we etched the shapes into the deep array. I believe they're 5 micron deep, but if you look at the scale bars, you can see that these lines are 1 micron, right? So this is possible to do. This is practically the densest pattern you can do very easily now that we have this auto developer in the lab. So if you have questions on how to achieve these kind of structures, just let me know. Right, and the one on the right is horizontal lines, and it's about 1.5 micron wide, 1-to-1 grade, right? Okay, so now I have a little demo here for you guys, just to show you how easy it is to use. All right, so you can see it has a touch screen. And all you have to do is just select the recipe that you want to use from the list. So right now I'm developing a 5-inch mask. It will open the load the recipe. Then what we do is we select the appropriate chuck for it. Just put it in. Then this mask is exposed with the MLA just prior to this process. Just put it in there. And we have to press the start button. That's it. That's all you have to do. The rest is done by the machine automatically. And you can see how it is doing it. So the developer will come, and it will fill the entire kind of surface of the mask, and then it will start shaking. This is useful because it always shakes it consistently, and just the same way each time you do this process, so you'll have process reliability basically, right? And you can actually already see the patterns are emerging because the developer is working. Fast forward a little bit, and now after that it starts rinsing it with the DI water nozzle over here, as you can see, and it will rinse it enough. We've tested this so that you don't have to worry about it. Just do some fancy motions over here. So let's just fast forward. And finally, it will just stop the VI water flow, and it will spin the mask until it is dry. So let's just go over more. All right. And it will return back to the original position you put it in. So it's easy to grab, and you can see our features in there. These are our logo, and they're exposed in grading lines, and similar to the ones I showed you earlier, and that's why they are colorful. All right. And actually, there's a I am actually doing a microscope investigation of this at the end, so that you can see how easy to make 1 micron grading lines using this machine. All right. There you go. Right. So these are 1 micron lines, but I believe the periodicity is 2.5 micron. All right. All right. So my part is over. So Xiaoning will take over from here.
Okay. Yeah. Let me share my screen. With my file. Screen share. So. Okay, so the acid etcher kicks in. Let me put the full top screen. Are you able to see this? Okay.
Yeah.
Okay. So for most of the work, after ending in yellow room, the users will bring their pattern to either dry etchers or acid etchers. So this is what we proposed about a year ago about. This is the automatic acid etching station. Well, current users, they know how painful it is to handle all those acid, and then how much they don't want to do the cleaning afterwards. So this is the, what is it, the bonus. So this is also the same as the equipment Serkan just talked about. It is all dry in, dry out. You don't have to handle any liquid. Bring your samples or photo mask and just throw inside this machine, and the machine does everything for you. You have no worry of cleaning, handling. And once the work is done, you open the door of the chamber, you get your sample clean and nice coming out. And also, this is a highly automatic equipment. We have a lot of strategies for fine control of your process. We can do different edge patterns, like we can do puddle etching. Just put a big puddle on top of your sample, or the spray, chemical spray etching. Currently, as this machine is new, and we have limited space, capacitance of the chemical. We only have 1 container for the chemical sauce.
How are you? How are you?
Hello?
Wednesday.
Okay. All right. So we do time the etching of the photo mask. Well, so here okay, this is it. So photo mask etching, we have 4-inch and 5-inch photo mask capability for oxide because of the chemical resource we have, and the machine has some capabilities to be further expanded for a few other chemicals. We'll talk about that at the end. So here, this is basically what user need for chemical etching is you bring in a sample, you have either photoresist or some other material as a etching mask on top of your functional layer. This is the black layer. That is the layer you want to etch. and you immerse it in the chemical, and the chemical takes away the unwanted part. Most commonly etched samples are the photo mask, either chrome masks or iron oxide masks, and all others are the patterns on silicon wafer, like the metal patterns, gold, copper, nickel, aluminum. That's the most common metal layers. We are also able to etch some silicon oxide layers and silicon nitride layers. So this is how we do photo mask etching, which is the most, unwanted part for users. This is the first step for user to use the photo mask to define other patterns. Here it is how you do it. I use this for photo mask training. See, first you got to prepare a container of the etchant, the chemical, and another container of the DI water. You immerse your photo mask inside the etchant, either slightly move it or give it some agitation or not. By the time you estimate it by estimation for most, this is very empirical. The time is done, you take the thing out and dip into the DI water to stop the etching. Okay, so now this is the time you use the timer on the acid hood, and stop the etching, bring it to the running DI water to further clean off all the chemicals. And the last step, which is also, I even don't want to do that much. This is a blow dry. Users know how much time it takes to blow dry a 4-inch and 5-inch photo mask. So a lot of water you need to get rid of. And at the end of the work, after you blow dry, that's the most unwanted part. You need to do the cleaning. All the containers, chemicals, you need to dump them to the, pre-designated area and wash them clean. Like this is a basic lab protocol to keep the containers clean for the next user. Okay. So here, we require user to know about the chemical you're handling. Actually, I think all the current user you will know, and the future user you have to get through this step. This is a little bit scary. Whenever you see it, even you do it many times, you have to read MSDS, the chemical safety data of what you're handling. When you read those data sheet, this is what's in your eyes. All the chemicals you're handling in our acid area are pretty dangerous, very dangerous. These signs are really really astonishing, scary. Big health dangers if you are not handling them correct. Some are even causing life-threatening situation, like the HF, sulfuric acid, nitric acid. So no one would no one would feel easy to work on this day after day, whenever you come. So by bringing this automatic acid etcher, so this is a close-up picture of the chamber you're working with. So because currently we have the process ready for the photo mask, users, you even don't have to choose the track, the holder for your sample. Our staff will help you to put in which size you need before you start using. What you need to do is come and open the door, put your mask on the holder, just loosely put it there. No other step, close the door. And this control screen is basically the same as, I'm gonna start playing, as the developer hood automatic one. Totally, you will have 3 or 4 pushes of the button, and the system start doing this, the puddle etch. So we do not shake it. This is because the viscosity of the molten acid, once we start shaking, the acid will flow away. So we'll keep the acid on your photo mask for about 2 minutes, and the system will start rinsing it automatically. At the end of the rinsing, the machine will do the blow dry and the spin dry. So the whole entire process, it is about 3.5 minutes. After this process is done, it is done. You don't have to think about any, cleaning. If you're dumping the chemical to the wrong places, or if you are cleaning the containers right, put them to the right location. If you have left the table clean, no more work. Once this is done, it is done completely. So let's see the last one. So the last video here, this is done after the photomask is etched and cleaned. No more liquid, not even a small droplet. What I show in this demo, it is the iron oxide photomask. In the future, we can expand the system to do the chrome mask too. Okay. So let's go to the next page. How do I go there? All right, so this is one of the just example to show you how fine this work it is. This is the pattern you are seeing is our calibration patterns generated from MLA 150. This is the photo optical microscope pictures. What you see this picture over here and here, these are the feature size with the photoresist on. And this is after etching, removing the photoresist, the actual feature size. We think this is pretty accurate and pretty fine etching. If you need to do finer image, we can go to SEM to take a better image. But however, for the feature size and the resolution of the microscope, the control is much better than the handling etching. So right now, this is what we have. We actually have the capability of 4-inch and 5-inch photomask. We actually already have the sample holders for 3-inch wafer, 4-inch wafer, and wafer chips. Here, what you see is the compartment of the chemical chamber. As you can see, this is the container for chemical. We currently only have one available. In the future, we'll have to ask, we may do a poll to ask the user what is the next chemical to add, and we'll apply for funding for fundings to add more chemicals to each up to 3 users from the cleaning, etching manual works. So finally, a recap what we can do with the wet and dry etching in NUFAB. Some are interchangeable, some not. Wet etching do most of the metal etchings, chrome, iron oxide, or iron, copper, gold, aluminum, nickel, titanium. And we also can do silicon oxide etching, which is mostly by HF, hydrofluoric acid, and the diluted hydrofluoric acid. This one, users can also go to the dry etching side. It all depends on your application and the process compatibility. If you have other materials that cannot either tolerate the wet etching or the dry etching. We also can do platinum moly etching and some other organic removal, which is a cleaning process by using a mixture of sulfuric and hydrogen peroxide, sulfuric acid and hydrogen peroxide. Based on what we have here, after we present our system today, users or future users among of you, if you have any need I mean, inside this list, or you want to expand the etching capability, take some of this among this list, bring it to the automatic etcher. You can let me know, let our director know. So we'll see which one will best benefit our users' need. So basically, this is what I have for the acid etcher. And Serkan, you want to talk a little bit about this? I think we have covered most of this, right?
Yeah. It's just to let you know that we're working really hard to figure out what you guys need and what we can expand our capabilities over here. So if you have chemicals in mind, if you want to see both in the automatic developer or etcher systems, just don't hesitate to let us know. All right, so we'll figure out which will serve the best to the whole community, and we'll see how we can help you guys better. Right. That's all I wanted to say. So if you have now questions, we can answer those.